We're going to spend some time drilling into the difference between synchronous and asynchronous JavaScript and look at some ways to implement that. This is of course relevant to both browser-side programming and server-side programming in the Node environment, both of which use JavaScript. You remember from before that the idea of synchronous execution is kind of what we expect from previous programming experience, that one piece of code is going to run in sequence just as the source code lays out. In effect, we have just a single thread of control that's executing that code. So one line of code at one time and then the next line of code after that. On the other hand, asynchronous execution, and asynchronous means outside of time, right? Async. The idea here is that you might have multiple threads of control that are running essentially independent of one another, which means that you might have code that executes kind of out of sequence. You might have code that runs for a while and then completes execution, and then that thread of control goes away. You've got quite a lot more flexibility, a richer model for execution of your code that's used a lot in JavaScript-based web programming. To give you some examples of why we might care about this, let's look at two things. One is an example on the browser. When we get to the point where we're writing single-page applications, we're going to have a lot of JavaScript that's running on the browser to provide a rich user interface for the end user. So the code that's running on the browser is going to be busy updating the display, it's going to be reading the mouse, looking at mouse clicks and looking at key presses and so forth, and then kind of animating the display, making it operate in a useful way for the end user. That's great, but we also, from the browser, are going to want to have to go back and fetch information from the web server, from our application server, to get data that's going to be displayed to the user. Now, if we were running using a synchronous execution model, when we got to the point where we wanted to make a network request, we would basically have to suspend the execution of the code that's keeping the user interface going, make a network request, wait for the response to come back, which could take several seconds, process that response, maybe update the display based on the data that we got back from the server, and then go back to running the application code. But during those seconds, or that time when the network request is taking place, the user interface is basically going to go dead or appear to be dormant to the end user. Clicks of the mouse and clicks on the keyboard aren't going to be processed, the display is not going to update, and that's not going to be a particularly compelling user interface. Instead, what we'd like to be able to do is run that network request in a separate thread of control. So when it comes time to make the network request, we want to be able to start up that request in a different thread and allow that thread to do all of the processing that I just described. Send the request, wait for the response, update the display with the response information, for example. Meanwhile, the user interface thread continues to execute, so the display doesn't appear to go dead or dormant. We've got two things that are essentially happening simultaneously in order to keep the user interface going while we're also satisfying the network request. A second example, which would be more on our application server under Node, would be that the application server, as we'll see, when it receives a request from the browser, is oftentimes going to want to go out to the database to request information from our persistent storage. And that database connection is also usually something that's done across a network, so it's going to require a separate connection to the database. It's going to require sending a request, waiting for the database to do the processing that's being asked to do, get the response back to us before the server code can continue to execute. So we've got this same kind of a thing where I've got sort of a long-running process to talk to the database, during which time the thread of control that's satisfying our web requests can't itself be running if we use the synchronous model. Instead, if we make that database request using an asynchronous execution model, the application code can continue to the application server code can continue to execute while that database request takes place. So on the client side, on the browser, asynchronous code helps us really dramatically improve the user interface experience. The user is just going to have a better time with the application because everything is going to continue to run and we're still going to be able to make network requests. On the server side, it has a lot more to do really with performance. If we've got a bunch of server-side processing going on that's just kind of sitting around waiting for database requests to take place, we're not going to be able to make very efficient or performant use of our web server. Instead, if we can do this asynchronously, we can get more performance out of our web server by not having all of the threads of control spending quite a lot of time just waiting for the database to respond, for example. So these are just a couple of examples of why it's important to be able to do asynchronous programming in a web development environment. For these next few examples, I'm going to basically be looking at server-side code as opposed to browser code, but the same sorts of ideas obtain for browser programming as well. So here's some example code that we'll use here. From the previous talk, you'll recall this accurate time and timestamp function that I'm just going to use to show kind of how this unfolds over time. You'll see here that I'm also loading up that moment module that we saw before, but I'm also going to bring in a different module here called FS. And this, because this is server-side code, it's going to run under the Node environment, and the FS module in Node is for accessing the file system. So anytime I want to open a file, close a file, read a file, write a file, delete a file, list files, I'm going to be making use of functions in this FS module. So I'm bringing that in just like I did with Moment so that I have access to it. And then I've got another little function here that's basically just going to kind of shorten output in order to fit more stuff on the screen here. The data that we're going to use here is this poem by Shelley that I really appreciate. It's sort of relevant to technology and the impact of technology over the longer term. Worth maybe pausing the video to read and reflect on yourself if you'd like. Let's take a look at how we might manipulate this file or access this file, and we'll start out by doing this with synchronous JavaScript. So I guess I've been emphasizing the importance of asynchronous JavaScript, but pretty much anything you can do in synchronous you can do asynchronously, and vice versa, just in terms of the basic functionality. So don't feel like you always have to use asynchronous code. You really only want to use it when you need to, for example, or well, according to the examples that I just gave. But we're going to start out by doing this synchronously so we can kind of see how it behaves, and then we'll use that to contrast with the asynchronous behavior. So here's an example of some synchronous JavaScript. The idea here is that we're going to again, I'm using these timestamp things. So we're going to print out read, and then what we're going to do is we're going to make a call to the file system module, and the file system module has a collection of functions that are synchronous and a collection that are asynchronous. That's not always the case for a particular node module, but in this case they support kind of both execution models. So the first thing we're going to do is use read file sync, and what we pass to read file sync, first of all, is the name of the file. So ozymandias.tech, that's this file here that I've shown you the contents of in the slide. And then we also have to give read file sync a second argument that is basically the encoding for the text in this file. So if you're familiar with Unicode and stuff, you'll know what this means. If not, just use that as kind of your standard encoding when you need to have something. So what's going to happen here is that the file system read file sync function is going to go out and open a file called ozymandias.tech in my current working directory, encoded as UTF-8, which is going to basically give us this stuff back. And it's going to store that in a variable called content. Well, it's a constant actually. This is another JavaScript ES6 thing that allows us to basically define a place to store something that is not allowed to be changed in the future. So I'm going to read this thing in once, and I'm initializing it with the contents of that file directly in this one statement. If I try to change it later on, JavaScript will grouse at me. So it amounts to a constant. Then I'm going to do another timestamp, and then I'm going to print out the first, or I'm going to print out the content that I read in, and this lead content is basically going to lop off some of the output to keep it from being so verbose. And then the timestamp will come out that shows that we've completed that operation. So let's go ahead and execute this code, Shift-Enter. And we can see here that we got some timestamps, and we saw the read first of all, then we read in the file itself, and then we saw this output timestamp, and then we saw a little bit of the beginning and the end of the Ozymandias poem. The lead content just gives us 100 characters at the beginning and 100 characters at the end, so we don't have the whole thing showing up. And then finally we have a timestamp that says done. And you notice that the way that these are coming out, that it all happens very quickly within a millisecond or two. But the sequencing is as we'd expect it from the contents of the source code. We see the read, we see the output, we see the done, and then undefined here is actually the return value from this function, which doesn't really return anything. So the timestamps are in the order that we'd expect them, and the read completes before the output is sent out to the console, right? We see the read, it gets done, and then we see the output, and then the contents of the poem. All right, so let's compare this to the behavior of an asynchronous function. So let me scroll this up here. What we're going to see is that the code that calls an asynchronous function is going to return right away. So when we call a function that's going to be run asynchronously, we immediately get that function immediately returns back to us, and we continue executing the next stage the next step in the code. So our code continues to go about its business, and that async function kind of goes about its business we could say in the background, or what I've been saying as in another thread of control. So just like accessing the database from our server-side code or making a network request from our browser-side code, that asynchronous function is going to kind of go about its business running in a separate thread. And that might take a long time. And of course, we're talking about computers that switch at billions of cycles per second. So a long time isn't really long by human standards, but if it's a few seconds, that's practically an eternity for the computer. So that process is going to run in the background, and when the operation completes, the request to the network or the request to the database or whatever it happens to be, that asynchronous function is going to call back to some code that we provided it, right? We're going to ask for this asynchronous behavior, say, for example, reading a file from disk. That's going to all go about its business behind the scenes to actually fetch the contents of that file from the file system. And when that file is available back in memory, it's going to do something that we've specified, right? At the end of the day, we're not doing these asynchronous things just to do them. We're doing them we're doing them with the purpose of actually running some code that we want to have executed when that long-running asynchronous thing completes. And the way that we'll do that to start with is by giving what's called a callback function. So a callback is, again, it's our code that we want to have it run after that asynchronous operation is complete. And we don't really know how long that asynchronous thing is going to take, right? It might take 2 seconds, it might take 10 seconds for a network request, or for a disk access, or for access to the database. All we want to do is be able to say, hey, whenever that asynchronous thing is done, run this code of ours. Okay. A couple of conventions here. These are conventions having to do with the way that node modules work. This isn't anything that's required. You don't have to implement asynchronous functions in this fashion, but when you're using a node module, just by convention, this is the way they all are written. So here's an example of the read file function, and this is now just read file, not read file sync, which is what we saw before. So the fact that we don't say sync means that this is an asynchronous function. That's kind of the default. And it takes the same initial arguments that we saw in the read file sync. The name of the file you want to read, ozymandias.tech, and then the encoding for the Unicode content. And it takes a third argument. This is the callback function. Okay. Think back to the greater than equal symbol, right? That should always trigger in your thinking that this is a function. We could write it as an ordinary function with the function keyword and stuff, but it's not idiomatic code that we'll use in this setting. So we see the equals greater than, that should right away trigger in our thinking, hey, that's a function. The stuff to the left of the fat arrow is going to be the parameter list. So this function is going to take 2 parameters, which we've called error and data. And the thing to the right of the fat arrow is the body of the function. And right now I'm just sort of showing this schematically as an empty body. So when this read file function gets run, first thing it's going to do is just return control back to our code. So whatever is next in the execution of our code is going to continue running. In the background, in a separate thread of control that's started by this read file function, there's going to be an attempt to read ozymandias.txt from disk, which is going to require quite a lot of monkeying around, calling out into the operating system and that kind of stuff. And when that's completed and the contents of that file have been read off of disk, the read file function is going to finish its operation by invoking this function that we've supplied for it. And it's going to pass in two things: an error value, which we'll talk about here in a second, and then the data that was actually read from the file. And then it's going to invoke this, whatever is in this function then is going to run with those two parameters available to it in order to do whatever it is that we're going to do with the contents of that file. Now that's in contrast, if I scoot back here to the synchronous code, right, when this thing runs, the read file sync, everything comes to a halt while that reading is taking place. The read file sync is going to do the same basic operations, go out and ask the file system for the contents of the ozymandias.txt file, and while that's happening, no other code is running here in our thread. We're not going to see this output run. We're not going to see anything happening beyond this. Effectively, what's happening is our code is coming to a halt while that subroutine that we've called inside of the Node ecosystem is going to do its reading from disk. When that's completely done, which again could take a while in computer terms, then we'll come back here and we'll execute this next statement and keep going. On the other hand, when we do read file, not with the sync that we just saw down below, that thing is going to return almost immediately after it starts up this separate thread of control and continue executing our code. Then sometime later, after that read has completed and the contents of the Ozymandias file has been read into memory, it's going to call the function that we supply as its third argument. Okay? Passing in an error object if there was a problem, and passing in the data from the file, the contents of the file, if everything worked okay. As an aside here, I want to say a few things about what is truth in JavaScript, and that's going to help us understand the behavior of the code we're about to look at in a moment. JavaScript uses this goofy terminology, Truthy and Falsey, to describe values as to how they will test when you use them in a Boolean context. So if you use them in an if statement or a while statement or anywhere else where there's a Boolean result that's expected, the expression will evaluate to either be truthy or falsy. And the way that it's defined, and this is a quote from the Mozilla Developer Network, which is a super helpful resource for JavaScript development if you're not already familiar with it. All values are truthy unless they're falsy, which I guess makes sense. So the falsy values are false, 0, an empty string, null, undefined, and not a number. Anything else, if it's evaluated in a Boolean context, will test to be true. Okay. Let's return then to this read file this asynchronous read file function. We're passing as the first argument to this callback of a value that's just typically called ERR for error. And again, this is a convention from the people behind Node. All of the functions in Node that take a callback are structured in this way. The very first argument is always going to be some kind of an error argument, basically a way for the callback to decide did it work or not. And then if there's additional information that's necessary to be passed to the callback, it will appear in additional arguments to that function. So error always shows up first. What we can learn from looking at the error flag or the error parameter is that if that value is falsy, that means that everything worked, right? The asynchronous function, in this case, the reading of ozymandias.txt off of disk, that if the error value, the error parameter is falsy, that means that worked properly and that we can expect to find the contents of that file in the data parameter. Okay. On the other hand, if the error parameter is truthy, that means something went haywire. The read didn't work properly. And then what we're going to see in the error value is an object that's a standard JavaScript error object. So error will contain a JavaScript error object. And that's the class name of the standard Java. Oops, didn't mean to do that. That's the class name of the standard JavaScript error object. So what we can do in that case is go look in the error object and fish out information about what might have gone wrong. So that error object, depending on how we're running, can contain just a message. It can contain a stack trace back, it contains lots of useful stuff. But a key thing to keep in mind when the error parameter is truthy, in other words, it contains that error object, any other parameters that are being passed to your callback function are basically going to have meaningless data. So if the read file function inside the fs module detects a problem when it tries to read ozymandias.tech, maybe the file doesn't exist or it's not readable by the current user or something, it's going to give you an error object here, and this next value isn't going to have anything meaningful. This is the reason that I pointed out the nature of truth and falsehood in JavaScript. When we're inside of our callback code, if we want to check to see if there was a problem here, all we have to do is see if that ERR parameter is truthy or falsy. And because in the case of an error in the underlying asynchronous function, if it's falsy, that means that it worked, and if it's truthy, it means that there was a problem. All right, so let's take a look at how we do that same operation that we did before, except now we're going to do it using asynchronous function calls. So back up here, we had synchronous read, everything happened in a nice sequence. Down here now, we're going to look at asynchronous read. Similar behavior here, we're going to print out a timestamp when we get started that we're about to do a read. We're going to print out another timestamp when we're done. And then in between, we want to actually do the read. Now, previously, we were able to just do this all in a nice, obvious, familiar kind of a sequence by lining up the statements one after the other. However, in this case, we're going to do something asynchronous. So we're going to use the read file function, pass in the arguments that we talked about previously, the name of the file and the Unicode encoding. And then this third parameter, basically the whole rest of this function call from here all the way to here, is our callback function. Okay, you can tell that it's a function because of the fat arrow. We know that the things to the left of the fat arrow are the parameter list, and the things to the right of the fat arrow are the function body statements. So when this thing executes, we should see the read come out. Then we're going to execute this read file, but that's going to start an asynchronous operation. It's going to create a new thread of control whose job it is to go read that file and then call our callback, and that's going to return right away. So we're going to then execute this statement, and then sometime later, after the read file actually completes, in other words, that separate thread of control finishes doing what we've asked it to do, our callback code is going to be called. The code from here down to here. So what's that callback going to do? Well, first thing, we're going to check to see if there was a problem. So if the error value that was passed in, again, by node convention, the first parameter is always an error value. If it's falsy, everything worked, and we can look in the other parameters if there are some to see what values came back. On the other hand, if that error value is truthy because because node passed an error object because it detected that something went haywire while it was reading the file, if it's truthy, then something went wrong. So one way to handle this is to just say if that's truthy, then I'm just going to basically rethrow the error. So that's going to just kind of punt this up the chain, and the JavaScript execution engine is going to have to deal with another error condition. Not a super elegant way of dealing with an error, but for this illustration, it'll do the job. Then we're going to do a timestamp, and then we're going to print out the contents of the file that we read. And notice that the value I'm passing into this lead content function that just gives us the beginning and the end of the content is the data argument. Again, the first parameter is going to be the error object. If it's truthy, something went wrong. If it's falsy, everything worked, and the rest of the parameters will have any additional information passed to them by node in order to allow us to access them. In the case of read file, the way it's defined is that the second argument is going to be the contents of the file that got read in. So we're passing that to our output function just like we did up here, except that previously that content was the return value from this synchronous read, and then we printed it out. Here, the value from the file is the data that was read in this asynchronous operation, which we're then printing out to the standard output. So let's execute this. Now you can see we saw the read come out. That's this statement, and then we executed this read file. Because read file is defined to start an asynchronous thing, a separate thread of control, what it does is it sets up that asynchronous operation, and then it returns right away. So the next thing we see in the output, in the same millisecond basically, is the done flag. And then actually this cell returns an undefined value. That's what this undefined means. And then a little later on, just 2 milliseconds in this case, but again, that's an eternity for a computer, we see output and then the contents of the beginning and the end of that poem from Shelley. Right? So although the code looks like it's going to do read, output the thing, and then done, that's not the way it unfolds in time. Right? This is synchronous. We're calling read file synchronously, but all it does is start up that asynchronous read file task and return right away back to us. So the next thing we do is run this statement. That's why we get the read and the done one right after the other in the same millisecond in this case. Then after the process of going out to the file system, opening the file, reading the contents in, closing the file, and passing the data back to us, we finally run our code and we see the remaining output here as shown. Another aspect of asynchronous function calls is that once you make an asynchronous function call, you're sort of stuck in asynchronous mode in some sense. For example, we can see here from this really simple read function that we won't know that the read function has finished doing its thing, that asynchronous function that reads from the file. We don't know that that's done until it calls our callback. If we wanted to do something else after the asynchronous read completes, we can't do it here in our code. We can't put it in the next statement down because, as we saw before, the execution model runs this synchronously, then it runs this synchronously, which starts that asynchronous process and returns right away, and then runs this synchronously and actually exits almost right away. And then later on, our callback function gets called once this file has been read in. So if we want to do something after the file gets read in, we got to do it inside the callback, right? Because that's the only place where we know we won't have anything running until the asynchronous thing is over. What happens is that if we're going to do something inside this callback function that is itself asynchronous, we're going to have a callback inside the callback. And if we do that for more asynchronous steps that we want to have happen one after the other, we're going to end up with callbacks inside of callbacks inside of callbacks. This is affectionately known as callback hell, or maybe less abruptly, the pyramid of doom. So here's an example that illustrates the pyramid of doom a little bit. Notice it. So the idea here is that we're going to list the contents of our directory, and then for each of the files in the directory, we're going to get some information about those files, and we're going to print out the size of the file. Now let me run this so you see what it's going to output. So this is just whatever I happen to have in this current working directory. There's a file name, has, and then some number of bytes. And you can see that each of these lines of output is coming from that console.log statement. The file name has some number of bytes, and I'm using, of course, a template literal to be able to display that. Now there's several asynchronous things that are going on here. The first thing I'm doing is calling, I'm in the fs package, which is part of Node, and one of the things that it provides is a function called readdir. And readdir takes as its first argument the directory, or a path to a directory that I want to read. So I'm basically listing the contents of the directory. And as a second argument, it takes a callback function. And that callback function, as usual in Node, the first argument is going to be an error parameter, so that readdir can tell me that there was a problem if there was one. And if not, the second argument is going to have a list of the file names that are in that directory. So readdir again when we run this function, it returns immediately after having spun up an asynchronous task whose job it is to read the contents of the current working directory, just the dot, this right here directory. When that reading is complete, it calls a callback function. Now, that callback function in this case goes from here all the way to here. Right, so that closing parenthesis is closing off this parenthesis. So all that's happening inside of readdir. Again, the reason being that I gotta make sure that I wait for the readdir operation to complete before I go off and try to get more information about the files in the directory, which we're going to see how that's done here in a second. I can't just include the code that tries to get more information on the files after this readdir function, because I'm going to execute that code right away before the readdir is complete. So I've got to put it inside the callback, and the callback is basically almost the entirety of this code. So when I get to here, the readdir will have completed, right? I don't know how long that's going to take, and I don't care because I'm just going to put this all inside the callback. So however long that takes, when the readdir is complete, my code's going to be invoked again. I'm going to check to see if there was an error. And in this case, I'm doing something even lamer than the previous example. I'm just printing out the fact that I got an error. And we'll see the different ways to handle that going forward. However, if the error value passed in here by readdir was falsy, I'm going to take the else clause. Now in that case, I know that the files argument, or the files parameter, is going to have a list of the file names in that directory. And what I'm going to do is just iterate through those things and ask how big they are. So the else clause here is going to take that files parameter and just use the standard iterator that's part of JavaScript. So this is an array of strings, and I'm going to run another function for each of the values in that array. That's just the way the standard for each works. Now, if you've used for each before, you might have used it with an ordinary function definition, but for the way for each works is it gets as an argument a function. And you can see here I've defined a function. I'm using, of course, a fat arrow function. And so this function has scope that goes from here to there, right? So this ran asynchronously. It called our callback when it got done. If we didn't have an error, we're gonna synchronously wander through all of the files that are in that list of files, and we're gonna call this function. And we're gonna pass to it as an argument the file name. Each of the entries in files is gonna be a file name. And again, you can see that because we have a fat arrow function, we know that everything on the left of the fat arrow is an argument or a parameter. And in this case, because we only have one parameter, we can drop the extra parentheses. And on the right of the fat arrow is the procedure body, and because it's got more than one statement, it's still limited by the curly braces. So this function is going to get invoked for every file that came in this list. Now within that function, we're going to make another asynchronous call out to node. So again, from this fs module, there is a function or a method called stat. This kind of goes back to old Unix naming conventions, but that stat function takes as an argument the name of a file. And what it does is it goes out to the file system and it pulls in information about that file, its name, its directory, its size, its modification date, its owner, that kind of stuff. And so what this function call is going to do is take that file name, and it's going to get that information from the file system. And because this is, again, it's a file system operation, it's going to take a while to go out to disk and read that information in. So it's written to be asynchronous. When that completes, when the information for that file name has been retrieved, one of two things is possible. Either it worked or it didn't work. If there was a problem reading that file's information, it's going to call the callback function with an error value. Again, the callback function in this case goes from here down to here, down to here, here. So if that error value is truthy, something went wrong. And again, I check to see if error is truthy. Now I'm going to say I can't stat that file. So again, I'm not doing much in the way of error handling, but I am doing something so that we can see that something went wrong. Otherwise, if the error value is falsy, that means it worked, And the additional parameters to this function, this callback function of ours, are going to be passed the information that was read about that file. So stats is going to contain a bunch of different information about that file. One of the things it's going to have is stats.size, which is the number of bytes in that file. So if the error value is falsy, we're going to take the else clause here and we're going to log out the file name that we're working on, which is this right here, that was passed to us as a parameter, has stats.size bytes, which is this that was passed to us as a parameter. And that's how we see the output in the example here. So we see the sizes of all these files. Now, that's a lot of monkeying around just to get the sizes of files. And what we'll see is that although this works, and kind of at the end of the day, the way that JavaScript asynchronous functions work is by using callbacks. We're going to see that as we go that there's two other mechanisms available to us. One's called promises, one's called the async await syntax. And those are both methods for improving upon this style of coding in order to do asynchronous operations. We can still do all the things we could here, but we're going to avoid this kind of callback hell, or as you can see, the pyramid of doom, right? There's this kind of pyramid tipped on its side, because every time we make a new asynchronous call, we're sort of going into another level of nesting to get the callback function. So if we had 5 or 6 of these lined up, we'd have a long pyramid of code and then a whole bunch of closed curly braces going out the other direction. We'd really like to avoid that. There's it's hard to do error handling. It's hard to deal with errors in the process of running these asynchronous calls. It just turns out to be a pain. So this is still the basic idea. We're going to call these things asynchronously, and when the asynchronous operation is done, it's going to call back to our code. That's always going to be the underlying behavior. We'll see that we have some other alternatives that will make it a little less painful to code by using some of these other paradigms.